Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 12 of the December daily lead code challenge, and after a very long time, and to be precise, after exact 10 days, now we are having an easy question. Okay, the first 2 days of the December daily lead code challenge we had easy questions, and from then on we were getting only medium level questions. Okay, some of them were on the harder side, some of them were slightly on the easier side also, but yeah, they were having the medium level tag. But this is the first time after 10 days that we are getting the easy questions again. Okay, the levels questions with the label easy. Let's see this question now. It's very simple actually, and yeah, you can see here like it's the range is around 10 power 3, which is very similar to what we get in the medium level questions. Say medium level actually we get 10 power 5 10 power 9, but this is 10 power 3, slightly less than that. But yeah, that is fine, but still it is marked as easy, because if you know the data structure that they are trying to target here, if you know the data structure, then it will be very very easy for you. So we'll see that how there are brute ways to do it at the same time. But yeah, if you know the data structure, then you will then you will get the hint that yeah, this is actually exact application of the data structure that they are talking about. Okay, but let's see this question now. You are given a integer array gifts. Okay, let's see the question here. They are giving you a gifts array which is gift basically means what? It's basically a positive integer, as simple as that. Okay, it's array of positive integers, and you are given a value k. So what you have to do? So you are given an integer gifts denoting the number of gifts in various files. Every second you are doing the following. Okay, that is every second you have to do these three things. Okay, what are that? Choose the pile with the maximum number of gifts. That is, choose the number among these which has the maximum value. Okay, first thing, if there is more than one pile with a maximum number of gifts, choose any. That is, if two piles, that is, if two numbers in this array are same. Okay, in this array, if two numbers are same, you can choose any one of them. Okay, you need not remember any one of them. You should not choose both of them. Leave behind the floor of the square root of the number of gifts in the pile. That is what I do. For example, 100 is here. First of all, take the square root of 100. What is the square root of 100? It is going to be 10. Then take the floor of 10. Floor, what is floor? Basically, see, okay, first let me explain what are the floor and what are these operations, so that you will get a clear understanding of what is happening. For example, let us say the value that we are taking is 5. Okay, what is square root of 5? It will be around, okay, like it will be around 2 point something, right? It will be 2 point and something and all. Okay, I'm writing 2 point something. Okay, as simple as that. Now, if you take the floor of this value, okay, if you take the floor of this value, okay, that is square root of 2. Okay, in Python we write it like it's into 0.5. Okay, if you take double star, basically this raised to, it's actually the raised to power. Okay, so here I'm writing 2 raised to power 0.5, which is square root of 2. Okay, if you take the value of this, what it will do, it will be, let us say it is 2 point something, then it will bring it down to the nearest, okay, the nearest smallest integer. Okay, in this case the nearest integer which is on the smaller side is going to be 2. So this value is actually going to be 2. Okay, for example, let us say you are having something like 2.76. Okay, you are having this particular value, still the floor will be getting it to floor. Okay, 2. Okay, you take the floor of this, basically still you are going to get the value of 2. Okay, that is something that you have to understand. Okay, you should be knowing what is the floor basically. Remember, floor and ceiling, see, there are multiple functions here. One is floor, the other one is ceiling, the other one is round will behave in a different way. Okay? But in floor, it's always clear that you should be always rounding off to the next smallest integer. Okay, that is the smallest integer near to this. Okay, so if you talk about 2, the next biggest integer is going to be 3. The next smallest is going to be 2. Okay, similarly, if you talk about negative numbers, let us say you have minus 1.78. Okay, yeah, you can write, yeah, minus 1.78. If you take the floor of this particular value, okay, what you're going to, can you quickly comment it out? So the value is going to be smallest. So in this case, you are going to get this minus 2. Okay, remember that it will not be minus 1, it will be minus 2. Why? Remember, next, that is, for example, see, this thing is between two numbers. Okay, what are the 2 and 3? So among 2 and 3, which is the smallest, you have to take that. Okay, simple as that. Similarly, if you take this number, it is between two numbers. What are they? They are between minus 1 and minus 2. Okay, this particular number is between minus 1 and minus 2. Among them, which is the smallest, minus 2. So that will be the floor value of that. Okay, as simple as that. So these things are something that you should be knowing before solving this question. So what they are saying, they're saying that whenever you see, you have to take the one which the maximum number. First of all, you have to take, in this case we have to start with 100. Then what you have to do is remove that number 100 and replace it with the floor value of the square root of 100. That is floor value of the square root of the maximum number. Okay, this we have to do for k number of times. Okay, that's what they're asking. Return the number of bits remaining after k seconds. So we'll quickly do a trace of this example. The example one is going to be very very simple, because all the numbers here are basically having perfect square roots. So let us see. First of all, you have to take 100. Okay, you have to take 100. the square root of 100 will be 10. The floor of 10 again will be 10. So you have to replace with that. Once you do that, see the the steps they are mentioning. If they exactly the same thing, that's why I'm not writing again and mentioning to you. This is the going to the first second. The next second, now this 100 is becoming 10. After that, can you quickly tell me what is the next biggest number? It is going to be 64. So in the next second, okay, you have to target 64, and the square root of 64 will be 8, and you have to keep 8 after that, okay, and so on. Here, basically, all the numbers are post, that is they are perfect squares. For that reason, you are going to get proper answers. For you don't know the floor function here. But once you are in such a scenario, you will be getting four numbers where you are not having the perfect squares. Okay, that in that case will be required. I'm not going to in details of it because you have to see. We are not going to simulate the floor function. We are going to directly use the floor function of the programming language that you are trying to use. So that's why I'm not going to in detail of it, because the function itself will take the care of the technicalities. Okay, so what you have to do is very simple. Every second, for example, seconds I mentioned, every second take the maximum value out of this. Okay, but pop out the maximum value. In that maximum value, what you have to do, replace it with the square root. If the square root is not a positive, that is not a proper integer, not a proper whole number, what you have to do, you have to floor that value, and then you have to insert it back to the data structure that we are using. Since the requirement is very very common in this, is similar to heap. Okay, what is heap basically? If you are doing a sort, see, first of all you have to understand what's the difference between a heap and a sort. There is heap sort also, but there is a slight difference in that. Try to understand this fact. If you are sorting, basically what is happening is, so let us say you are sorting a given array. Let us say you are sorting this array. So the first value that you are going to get will be the highest value, the second will be the second highest value, and so on. But in case of heap, what it is done is, remember, the first value in heap again is going to be the highest value, but the second value in heap need not be the second highest value. Okay, that is what I'm trying to tell you. Heap, the function, the way it functions is that it will always give you either the smallest or the biggest value only. Okay, when you pop, you are going to get the smallest or the biggest value. Okay, depending on the type of it is a mini heap or a maxi heap, depending on that. Okay, but if you try to, then after popping the first value, if you pop it again, then you can get the second largest value. But if you see, the idea here is, without popping, if you simply try to take the zeroth value in the array, for example, this array I am using for heap. See, instead of doing heap pop, if you try to simply try to take the zero value or the first value or the second value in the index onwards, that is the zeroth index, first index, second onwards, you are not going to get the second highest or third highest value like that. Okay, because the way heap function is that it will only return the highest value. Once after returning the highest value, if you are popping it again, then it will get the second highest value. If without popping, you're trying to get the value using the index, you are not going to get the second highest value. Okay, this is the exact requirement here. At a time, we only need the max value. We don't need the second max value at that moment. Okay, in the single iteration, we don't need that. Okay, so every time we need the max value only. Okay, as simple as that in every iteration. So that for that reason, heap is going to the most suitable data structure here. So let us see how it works. So first of all, in Python, if you're talking about, this is the library that we are using for heap. Okay, heap library. And by remember that there is one drawback here. The way it functions is actually that of a min heap. Okay, that's why I'm giving the name itself a min heap. Min heap basically means when you do the pop, it will return the smallest value. But in our case, we are requiring the opposite way. That is, we want the max value to be returned. Okay, that is, we want a max heap. Okay, but in the heap Q library that we're using, we cannot get that by default. So to simulate the max heap using a min heap, what you have to do, basically when you are inserting these values in your min heap, you have to basically insert them with a minus sign. Okay, that is, if they're positive, insert them with a minus sign. If they're negative, make them positive and then insert. Okay, that is, before inserting every number, just multiply them with -1, so that we are getting the simulation of a max heap using a min heap. Okay, as simple as that. Fine. So this is something that I'm going to do. This part will be there every time. Okay, see, wherever you're seeing the pop or push operations, you will see that I am basically doing a multiplication with -1, and then I'm using them. Okay, as simple as that. Even while pushing, even while popping. Okay, as simple as that. So as you can see, this is going to be my min heap data structure that I'm going to create. So yeah, all values, as you can see, I have multiple them in -1, then I'm putting them in the heap. This is the first thing. Next, what you have to do, you have to first heapify. Okay, heapify basically means that it will start the construction of the heap. Okay, because heap works in a certain way, right? There's a tree to be formed. Okay, there's a tree formation happening, and the child trees and so on. Okay, fine. This will take off and time in the time complexity terms. Okay, fine. After that, we can start the iteration. That is, for each second now we are going to start the iteration. We are going to start the calculations. So basically, for each second, what you have to do, we have to pop the max value. Okay, remember that. For example, 100 going with the first value that will be popped. Okay, once that value is popped, since while inserting itself, I've multiplied them -1. That's why when they're being popped out, I will again multiply them with -1. Okay, to get the original value back. Okay, so this will be the original value. Remember, every push and pop operation takes O of log n time. Okay, as simple as that. Where n is the current number of elements that a heap is having. Okay, as simple as that. Fine. Once the element is popped, what you have to do, you will have to do, first of all, take the square root of it and take the floor of the square root, and then again, since it's being inserted into the heap, and we want to simulate max heap in terms of min heap, so we have to, while inserting again, we have to multiply with -1. Okay, this is the actual thing. Okay, and this basically we are doing because in this is specific to the Python language only, because the library that we're using doesn't support max heap. So using min heap only, we have to simulate max heap. For that reason, I'm multiplying with -1. Okay, again, these are like pop and push operations, so both of these are going to take log n time only. So if you see, this whole loop basically is taking k into log n time. Okay, okay, I will come to the time complexity separately. First, see the calculations here. Fine. Once I have done all of these, after k seconds, I have to basically return this sum. Again, while calculating the sum, what I will do, remember one thing: all the elements in this heap are basically having a one extra minus sign. Okay, so while taking the sum, you have to ensure that you are removing that minus sign. Okay, so I'm going through all the values in this min heap, and while taking the sum, I'm multiplying them with -1, and then I'm taking the sum. Okay, let me quickly run this and show it to you. So as you can see, this is clearing basically all the test cases. I've already submitted this solution. This is going to the most optimal solution in this case, because this meets the exact requirement that we are having. We are not doing anything more. We are not doing anything less. Remember that the what normally people will think is that if you're not good in programming, if you're not aware of the heap data structure, that is the priority queue, what you will think is that, let me sort it out in every iteration. That is what you will do is, in this for loop, basically you will try to sort every time. Okay, so what will happen? I see, sorting is fine. You will get the max value every time, but the requirement here is, see, in each iteration we only need the max value. We do not need any value other than that. At least we don't need the second hash value, the third hash value, and so on. We don't need them, right? So that is the reason why the heap is going to the max here, because see, each basically iteration is only going to take log n time. Okay, only going to take log n time. But if you are sorting in each iteration, the sorting itself will take n log n time, and you are having k iterations, so it is going to take k into n log n time. Remember that. But in our case, it is going to take only k into log n time. So this is the time that we are going to save because of this data structure. So that should be appreciated, because that is the main advantage of using this data structure. Okay, so many people while studying do not understand the purpose of heap. This is the purpose of heap, basically, where you only require the max element. You are not bothered about the second hash, third hash, and all so on, right? You only need the max value at a time. So in that case, you can go for the heap data structure, because uh, that will basically give in the the hash value in the log n time. Okay, that is after popping that value out. Once you have to like re-maintain that data structure, right? To do that, basically just going to take log n time, right, to get the next value. So this is the one, and this is what I wanted to show you. Fine. And yeah, first we have to take the sum. So my like request to you, will you, like, when you're seeing this question and if you're able to solve it in first go, do not waste your time much, because this easy question, I understand that. So what you can do is try to understand how the heap works, basically. Okay, that can be a homework for you. Just try to do a deep dive on this topic, how the heap works, basically. The idea here is, see, you will ask me, while I'm popping it out, why should I have a time complexity? First of all, for example, in a sort, what you are doing, once you have sorted, you can just take the zeroth element, right? Or you can just take the n-1 element after the sorting. That will give you the max or the smallest value, right? In this case, why even for popping, why I'm having a time complexity? So the reason here is that once you pop, basically, that the way the heap works is, it's basically a tree. So the root is going to be the value that's only popped out. So once the value is popped out, basically, one, you will have to take the last value, that is the last child value you have to take, which is a leaf. You have to take the leaf value, and then you have to replace it to the root of the tree, and then you have to do a downward kind of sort. Okay, that is, yeah, it will come down. That particular root will combine with the child, and so on. It will be like a flow then. Okay, that will take log n time, basically. Okay, and same in the case of a push, basically. So whenever you are pushing some values in a heap, basically, what is happening is that will be inserted as a leaf. Okay, then again the same thing will happen. The similar sort will happen, that it will be going one level up and up, and so on, like that. Okay, that is for every two values will be compared to its parent, and so on, like those things will be happening. So please try to understand how the heap functions, because in such questions, if this comes in interview, the aspect of the interview will be to first of all test your knowledge, whether you are able to apply the data structure in this case or not, first thing. After that, they will ask you how this works internally, basically. You may have to draw some diagrams and explain them. So if this such a question comes, see, this is the way to prepare, basically. Okay, the lead code, you should not just solve and be happy and enjoy the rest of the day. It's not like that. Every question there is an objective, basically. So these are the real questions that are coming in interview. Okay, so I agree, like, this is the easier side. You cannot expect this to be a fang level question, but yeah, if this comes, be prepared of what else can come. Okay, just have different ways to do it. For example, it's the same question, so there are at least two to three ways of doing the same. As I mentioned, one could be like, you can use sort and do it. Okay, the other could be brute force approach. The other could be as an optimal approach, like this, where you're using the exact data structure built for this. This is exact application of Jeep. Okay, we are not wasting any complexity here. We are not doing any waste calculations here, which are not useful as well. Okay, so that is the reason why I want to emphasize that. Please understand those things also. Those are going to be a lot of important role when you are going to sit in front of interview. Okay, we'll be very confident those times if you've done this kind of preparation. So yeah, friend, that was all for this video. Okay, yeah, as I mentioned, this whole thing is going to take k into login time. And if you see this part of the heapify part, well, this is the initial formation of the heap structure, the tree basically, it's going to take off n time. So if you talk about the time complexity, it's going to be n plus k into log n time. And if you talk about space complexity, since we are having a separate array for that, okay, so again it will take off n time because there are n values in this. Okay, as simple as that. So yeah, friend, that was all for this video. If you like my parts, please do consider subscribe to my channel. And this is around day 12. We are almost mid of the December daily LeetCode challenge. If you like my words, please do subscribe to my channel. I am sure that I can provide you what you require, because see, my aim is to provide a quality content to in a freely available manner so that everyone can benefit out of it. And see, it's not about just uploading a video and just putting video randomly. I am just, what my aim is that if you subscribe to my channel, I can give you guarantee that I will be putting all videos for the whole month, at least for the whole month, so in such a way that you will get benefit out of it, that you will get some motivation to solve this kind of questions daily. So that is my aim, that it's not just about the solution or the quality of the solution, it's also about the regularity, the continuation, the consistency. So I hope you like my initiative. If you like, please subscribe. This really gives a lot of motivation. This basically gives a certification for me that yeah, my efforts are reaching someone, it's helping someone, it's not a waste for me or for them. So yeah, that was all for today. See you tomorrow. Thanks a lot.